Hello good people, I'm going to talk about fractions. To help me do that, I'm going to bring in a square. Why a square and not a circle? Well, I did not want to cut any corners. Right now, this square represents 100% of an area. A fraction is a part of a whole. To begin with, I'm going to divide this square into two. From a mathematical point of view, I've taken 1 and I've divided it by 2. I can express that as a fraction, and it would be 1/2. If I absolutely insisted, I could express this as a decimal. 1 divided by 2, or 1/2, is same as 0.5. And if I absolutely insisted on a percentage, well, I could say that 1/2 is 50% of the original square. I could have also divided the original square by 4. 1 divided by 4 is same as 1/4. And expressed as a decimal, that would be 0.25. And if I wanted a percentage, well, that would be 25%. I can also divide the original square into 20 equal parts. 1 divided by 20 can be expressed as 1/20th. As a decimal, that would be 0.05. And as a percentage, that would be 5%. This means that the green bar is 1/20th of the original square, or 5% of the original square. But why stop at 5%? I could take the original square and divide it by 100. Now, each yellow square represents 1/100th of the original square. Or if I insisted on decimals, it would be 0.01 or 1%. In terms of mathematical language, when we have a fraction, the value above the line is known as the numerator, and it represents the number of parts, while the value below the line is known as the denominator, and it represents the size of the part. The line that separates the numerator from the denominator is known as the division line or the vinculum. From a mathematical operations point of view, the division line or the vinculum serves the same function as the division symbol. Fractions, decimals, and percentages are three different ways of expressing the same quantity. In this particular case, I could say that the blue square is 1/4 of the original square, 0.25 of the original square, or 25% of the original square. I am using different formats to express the same quantity. What is more, I can use different fractions to express the same quantity. For example, if I am talking about 1/2, what would that be in terms of quarters? In other words, how many of these blue squares fit into this red rectangle? By observation alone, we could say 2. And so 1/2 is the same as 2/4. What is that in terms of 20ths? How many of these green bars fit into this red rectangle? Again, by inspection, I could say that 5 of these green bars would fit into a blue square, and because there are 2 blue squares in each red rectangle, there would be 10 green bars. And so I could say that 1/2 is the same as 2/4 is the same as 10/20ths. What is 1/2 in terms of 100ths? By inspection, 5 of these yellow squares will fit into the green bar. And seeing how 10 bars make a half, I would need 50 100ths to also make a half. If I was to divide these numbers, I would find out that it all checks out. 1 divided by 2 is 0.5, 2 divided by 4 is also 0.5, 10 divided by 20 is 0.5, and finally 50 divided by 100 is 0.5. Fractions that represent the same quantity are known as equivalent fractions. Of these 4 equivalent fractions, 1/2 represents the simplest form for this quantity. In terms of definitions, A fraction is said to be in its simplest form when its numerator and denominator no longer have a common factor. Recall that a common factor is a value that both of these numbers are divisible by. That is all for now, and I will see you on the flip side.